Welcome to the DIY Honda Garage channel. Today, we will be discussing the specific Diagnostic Trouble Code DTC P16BC related to the 2008 to 2012 Honda Accord. This code signifies a low-voltage situation in the alternator field relay (FR) terminal circuit or the ignition power (IGP) circuit. The alternator plays a crucial role in the electrical system by converting mechanical energy from the engine into electrical energy, thus charging the battery and powering the vehicle's electrical components while the engine is running. The alternator's FR terminal is connected to the voltage regulator, which controls the alternator's output to maintain the battery charge. Understanding this DTC is essential for diagnosing potential issues with the vehicle's charging system, which can lead to electrical failures if not addressed promptly. In this presentation, we will cover the steps necessary for efficient troubleshooting and resolution of this issue. The DTC P16BC refers to an issue with the alternator FR terminal circuit or ignition power circuit where the voltage levels are lower than expected. The alternator's FR terminal is vital for regulating the output voltage via the internal voltage regulator, and a low voltage condition can disrupt the entire charging system. The IGP circuit supplies power to various ignition and electrical components. These components primarily reside within the engine compartment. Near the front, where the alternator is mounted, the alternator itself is positioned on the engine block, typically on the passenger side. If there are issues with the FR terminal connection or IGP circuit, it can lead to performance problems, including an inability to maintain battery charge. Thus, pinpointing the exact failure location and its connection to the alternator is essential for proper repairs. Several factors could lead to the DTC P16BC being triggered in your Honda Accord. First, poor connections at the alternator 4P connector can cause insufficient voltage to be transmitted, leading to a failure in the circuit. Secondly, loose terminals can disrupt the proper function of electrical components, preventing the alternator from receiving the necessary power to operate effectively. A corroded mounting surface can also be an issue, as it can hinder the physical connection between the alternator and the engine, affecting connectivity and grounding needed for its operation. Lastly, an open circuit in the wiring between the alternator and the corresponding fuse can prevent voltage from reaching the alternator, triggering this error code. Identifying these possible causes is crucial for effective troubleshooting and repair. When experiencing the DTC P16BC error code, several symptoms may manifest, indicating a problem with the alternator's functionality. Primary among these is the failure of the engine to charge the battery effectively, leading to a drained battery over time. Electrical components, such as the radio, lights, and dashboard functions, may begin to malfunction as they rely on a stable power supply. Additionally, the driver might notice warning lights illuminating on the dashboard, which can include battery or alternator-specific indicators, alerting them to the charging issue. In some cases, you may encounter difficulty starting the vehicle, especially if the battery has been completely drained. Together, these symptoms highlight the need for immediate attention to the alternator and associated circuits. In the first step of resolving the DTC P16BC issue, it is critical to check for poor connections or loose terminals at the alternator 4P connector. Begin by visually inspecting the connector to ensure that all terminals are securely attached and free of corrosion or dirt, as these can impede electrical flow. Loose connections can create intermittent issues that make diagnosing the problem challenging, so ensure each connector is properly seated. If any connections appear compromised, they should be repaired before moving on to the next steps of troubleshooting. Once you've established that the connections are secure and functioning correctly, you can confidently proceed to Step 2 for further investigation. The second step in troubleshooting DTC P16BC involves checking the mounting surface of the alternator for corrosion. Corrosion can significantly affect the electrical grounding needed for the alternator to function correctly, leading to potential voltage issues. If corrosion is detected, it is essential to remove the alternator to clean all mounting surfaces thoroughly. Use a wire brush or suitable cleaning solution to remove any oxide or rust that could interfere with the electrical connection. This step ensures a solid ground, which is critical for the alternator's operation. After cleaning the surface, reinstall the alternator carefully and proceed to the next steps in the diagnostic process. For the third step, turning the ignition switch to the on position 2 is necessary. This action powers the vehicle's electrical systems without starting the engine, allowing the use of diagnostic tools. It's essential to have the Honda Diagnostic System, HDS, ready at this point, as it will be necessary for clearing previously recorded DTCs. Ensuring that all electrical connections are operational before this step can prevent complications. Note that the ignition should not be turned to the start position, as this can introduce confusion in the diagnostic process. Once the vehicle is in the appropriate state, you're prepared to clear any existing error codes. In this step, you will clear the DTC using the Honda Diagnostic System, HDS. This process resets any recorded diagnostic trouble codes that may still be residing in the vehicle's computer. It is crucial to clear these codes before running new tests to avoid confusion with previously logged issues. Clearing the DTC will allow you to monitor the system's response to new conditions without interference from historical data. Ensure the HDS is connected properly and follow the prompted steps to clear the codes. After completing this step, prepare to start the engine and observe how the system responds. Next, Step 5 involves starting the engine of your Honda Accord. This action allows for immediate testing of the alternator and its associated circuits under load. Once the engine is running, it's essential to monitor how the electrical components respond. Make sure the climate control settings are optimal for testing. AC on, temperature at maximum cool, blower fan at maximum speed, rear window defogger activated, and headlights on high beam. These conditions will draw significant power from the alternator, emphasizing any potential faults. Pay close attention to whether any warning lights on the dashboard illuminate during this phase, as they could indicate existing issues. The sixth step requires you to hold the engine speed at 2,000 RPM for 1 minute. This step is crucial as it places the alternator under a consistent load, allowing for better assessment of its performance. If you have an automatic transmission, AT, in park or neutral, or a manual transmission, MT, in neutral, gently apply the throttle to maintain this RPM without stalling. This sustained high RPM is essential to simulate high electrical load conditions, which can help in detecting any intermittent issues with the alternator's output. Observing how the vehicle responds during this phase will provide valuable data about its charging system efficiency. Upon holding the engine speed, the next step is to check for any pending or confirmed DTCs using the Honda Diagnostic System, HDS. This will confirm whether the DTC P16BC or another error code has reappeared. If the same DTC is indicated, it implies that a fault still exists in the alternator circuit, despite previous checks and repairs. If, however, there are no DTCs currently displayed, it may indicate an intermittent failure, suggesting that the alternator system is functioning correctly at that moment. It's important to document any findings and reevaluate previous troubleshooting steps if the error persists. Keep in mind that intermittent issues may require ongoing monitoring or more extensive diagnostics. In the eighth step, you need to turn the ignition switch to the lock position 0 to safely disconnect power from the system. Following this, disconnect the alternator's 4P connector. It's critical to perform this action after verifying that the engine and electrical system are properly shut down to avoid shock or damage. This disconnection allows you to conduct a focused test on the alternator circuit, particularly checking for voltage at the terminals. Ensure you have the proper safety equipment while performing these actions to prevent accidents. Once the connector is removed, you'll be ready to measure voltage and further diagnose the issue. The 9th troubleshooting step involves turning the ignition switch back to the on position 2 to initiate the voltage test. With the ignition on, measure the voltage between alternator 4P connector terminal number 1 and the body ground. This test is vital as it indicates whether battery voltage is reaching the alternator's input line. A reading of battery voltage would confirm that the circuit is intact up to this point. If the voltage is present, you will proceed to further steps in the diagnostics related to the alternator's output. Conversely, if there is no battery voltage present, it indicates a potential break in the circuit, which calls for further investigation into the wiring and fuses. After completing all troubleshooting steps and implementing corrective measures, the final repair verification is crucial to ensure the resolution of the DTC P16BC. Start by retesting the electrical system under the same conditions to confirm that the alternator is functioning properly and supplying adequate charge to the battery. Clear any DTCs with the HDS and observe for recurrences during operation. Additionally, double-check all connections made during repairs to verify their security and integrity, as loose connections can lead to recurrence of issues. A thorough review of the system will confirm that the DTC has been resolved, ensuring longevity and reliability in vehicle performance. Preventive maintenance plays a significant role in avoiding DTC P16BC and similar issues in the future. Regular inspections of electrical connections, particularly those related to the alternator, should be done to identify any corrosion or loose terminals early. If visible corrosion is detected, clean it promptly to ensure optimal electrical flow. Also, regularly check the battery terminals for tightness to prevent intermittent issues that can arise from loose connections. Implementing these preventive measures aids in maintaining the robustness of the alternator circuit, extending the longevity of the vehicle's electrical system, and ensuring the reliability of your Honda Accord. In summary, the DTC P16BC signifies a low voltage issue within the alternator FR terminal circuit or the IGP circuit, requiring thorough troubleshooting. We have discussed multiple steps, from checking connections to measuring voltage levels and performing necessary repairs. Each step is critical to ensure the alternator functions properly, which is vital for the longevity and reliability of your electrical system. By meticulously following the troubleshooting guide, you can isolate the issue effectively. And by incorporating preventive maintenance practices, you can significantly reduce the likelihood of future occurrences. Remember that understanding the roles of components and how they interact is essential for effective vehicle diagnosis and repair. Please like and subscribe to the channel. See you next time.